I am Sunil Kumar Bhatta. So today in this video lecture series, we will discuss about the subject circuit and network theory, and from this subject I will explain you very important analysis, that is super mesh analysis. So let us start. So this is my course outline. In the course outline, first we will discuss about the definition, what is super mesh, we will know. Then steps for solving super mesh, how to solve a super mesh analysis problem, that is the second point. And third and fourth point, that is the example. So I have taken two problem, and we will know how to solve this super mesh analysis problem. Coming to next slide. So that is the definition. So what is super mesh? So before starting super mesh, already we know that is mesh analysis. So mesh analysis and super mesh analysis, what is the difference here? So as we know, mesh is a closed loop where no other loop is present, that is called mesh. And what is super mesh? So mesh analysis, I am taking one circuit, there you can better understand what is super mesh and what is mesh analysis. So I am taking one circuit here. So very simple circuit I am drawing here. So here two sources present, voltage source, current source, some resistances are present, and another circuit I am taking here. So that is one voltage source is connected, some resistances, and here one current source is connected. Okay. So in this two circuit, you can see in the first circuit here it is a mesh and it is another mesh. So two mesh is present, and in, as we know, in mesh analysis problem we apply KVL, Kirchhoff's voltage law, to solve the problem. So here in the mesh, first mesh you can apply KVL, and in the second mesh also you can directly write down the current value, because current source is connected in a branch here, so directly we can solve. But in the second circuit, here you can observe one current source that is present between two mesh. So in the second circuit also two mesh is present, this is one mesh, this is another mesh. So you can see for this two mesh, one common current source is connected. So how to solve this kind of problem? This is a complex circuit, common current source is present, so we cannot write the KVL equation here. The current value we cannot write, because a current source is present between two mesh. So how to solve this kind of circuit, this kind of complex circuit, how we can solve? So that is called your super mesh analysis. So now what is super mesh? So a super mesh forms when two meshes have a common current source. If a common current source is present between two meshes, then that is known as super mesh. That two meshes constitute a super mesh. That is the super mesh. A super mesh analysis is a better technique to analyze such a complex electric circuit or network where two meshes have a current source as a common element. So it is a better technique we can use to solve such kind of your complex circuit. Then number 3, here one example, one circuit is there in the PPT. You can see in this circuit here how many meshes are present. 3 meshes are present. So 3 meshes, you can see this is one mesh, this is second mesh, this is third mesh. So we can say in this circuit one common current source is present. What is that common current source? This is the 5 ampere common current source is connected between mesh 1 and mesh 3. So we can say this mesh 1 and mesh 3 that constitute a super mesh. This is called super mesh. Super mesh. So that is called super mesh. This common current source, due to this common current source, this mesh 1 and mesh 3, that will be known as a super mesh. So this is all about the super mesh. So now how to solve this kind of problem? So in the next slide we will discuss how to solve, or what is the steps how to solve this kind of problem. Yes, coming to the next slide, that is the steps for solving super mesh. So you can see here the 3 steps it is written. These 3 steps that will tell you I mean how to write the equation for super mesh. Like in mesh analysis, by applying KVL we are able to write the equation. So like here 3 steps that is written here, and by using this 3 step we can write the equation. So first step, first write the equation for the mesh which is not a super mesh. So first you have to see how many meshes are present in a problem, and after finding the meshes, there you have to check which mesh is not a super mesh. So in the previous slide, you can see here out of 3 meshes, the mesh 2. So this was the mesh 2 I had taken. So this is mesh 1, this is mesh 3, and mesh 2. This is mesh 2. So mesh 2 that is not a super mesh because common current source is not connected to mesh 2. So that is a super mesh. So first we will write the equation, the mesh which is not a super mesh. So here mesh 2, that is not a super mesh. So coming to the next point. In the second point, secondly, formulate the current equation for the current source present between the 2 meshes. So current equation, the common current source, for that common current source we have to write the equation. So that is the second equation, that will be the second equation. Formulate the current equation from the current source present between 2 meshes. What is the third step? Write the KVL equation in the outer path of the super mesh, and during that time, while writing the KVL equation for the outer path of the super mesh, do not consider the branch of the circuit which contains current source. So here you can see in the previous slide one example, one circuit is drawn here. So in the outer path, so here I am telling you how to write the what is the outer path. So for this 2 mesh, the 2 mesh which is super mesh, for this 2 mesh when you write equation, you don't need to consider this branch. Don't consider this branch. So you think this branch is removed, and in the outer path, so outer path means from the 2 ohm to 20 volt, 8 ohm, 5 ohm, and in 4 ohm. So in the outer path you have to write equation by applying KVL. So that is the third step. First step, what is the first step? The first step is the mesh which is not a super mesh, there you have to apply KVL and you have to write the equation. So this is the first method. As here this is mesh 3, this is the mesh 2, this is not a super mesh. So by applying KVL we can write the equation here. This is the first method. Second method, that is for the current equation, for this common current source. The common current source, I will tell you how to write the equation, that I will tell you. So this is the second equation. And what is the third equation? The third equation is in the outer path. Okay, in the outer part of the super mesh, there you have to write the equation by applying KVL. So this is all about the steps. Now I have taken two problem that I will explain. So coming to the slide. Yes, so in the example 1, you can see in the example 1, so that is one circuit that is here, that is drawn here. So in this circuit, how many meshes? First you have to see how many meshes are present. So you can see here 3 meshes are present. So this is mesh 1, I am numbering it, mesh 1, mesh 2 and mesh 3. So 3 meshes are present. So in the out of 3 meshes, you can see the common current source is connected between mesh 2 and mesh 3. So here mesh 2 and mesh 3, the common current source, this 4 ampere current source is connected. So now that is we concluded that the mesh 2 and mesh 3, it is a super mesh. It is a super mesh. It is a super mesh. So as I said in the second slide, the steps. So here by the 3 steps we can write the equation and we can solve the problem. So in this problem the question asks find current through the 10 ohm resistor by using super mesh analysis. So you can see the 10 ohm resistor is connected here. So by using super mesh analysis we have to calculate the current across 10 ohm. So what is the equation? First we will write the equation. So you can see the equation we can write. So the mesh which is not a super mesh, so you can see the mesh which is not a super mesh, the mesh 1 that is not a super mesh. So by applying KVL we can write the equation for this mesh. So in this mesh 2 volt is connected, 1 ohm is connected, 10 ohm is connected. Very simple, by applying KVL. So here applying KVL to mesh 1, so that is 2 volt, so plus 2, then minus this 1 ohm resistor, current I1 is flowing, so that is minus 1 into I1, then current is coming to your 10 ohm. So in 10 ohm that is 2 current is flowing, one is your I1, second is the I2. So I1 I2 direction that is opposite, so that is minus 10 I1 minus I2 equal to 0. Then after opening the bracket you will get 11 I1 minus 10 I2 equal to 2. So this is equation number 1. So this is the equation number 1. So first equation that is written here, first equation means the mesh which is not a super mesh, for that mesh the equation that is written by applying KVL. So coming to the next slide, in the second equation, what is the second equation? The second equation is for the current source, the common current source. The common current source is here 4 ampere. So for this 4 ampere, for this 4 ampere, the common current source, you have to write the equation. Yes, you have to write the equation. So here 4 ampere, you can see. So for current equation, how to write this? You have to observe 4 ampere current source direction, that is upward, and in 4 ampere the I2 is flowing, I3 is flowing. So out of I2 and I3, the I3 direction that is upward and I2 direction that is downward. So we will write the current equation to the super mesh, that is I3 minus I2 equal to 4. That is the second equation. This is called your second equation for the common current source. So here I3 minus I2 equal to 4. Why? Because 4 ampere current source direction is upward and I3 direction that is also upward and I2 direction that is downward. So that is I3 minus I2 equal to 4. That is second equation. Then coming to the third equation. So third equation, what is the third equation? The third equation, earlier I told you that in the outer path of the super mesh, they are, by applying KVL you can write the equation. So here, and during that time you have to consider the 4 ampere branch, the current source branch, that is not connected. So here in the outer, by applying KVL to the outer path of the super mesh, so we can write in the outer path means the 10 ohm, then 5 ohm, then 15 ohm. So in the 10 ohm the I2 and I1 current is flowing, so that is written minus 10 I2 minus I1. Then in the 5 ohm only I2 current is flowing, so that is minus 5 into I2. Then after 5 ohm the outer path, this branch that is not connected here, you have to assume this. Then in the 15 ohm the I3 current is flowing, so that is minus 15 I3 equal to 0. So after opening the bracket, then if you solve, then you will get 10 I1 minus 15 I2 minus 15 I3 equal to 0. So finally we got 3 equation. So for the 3 mesh, 3 equation that is done. So after, but the problem is that is not solved yet. So question asks the current through the 10 ohm. So current through the 10 ohm. So for current through the 10 ohm, so we need to know what is the current value I2, what is the current value I1. So after calculating I2 and I1, we can able to say what is the current value in 10 ohm. So here you see, after solving the equation in the next slide. So after solving the equation, you can see, after solving the equation, the three equation, so that is the I1 is value is coming minus 2.35 ampere, I2 value is coming minus 2.78 ampere, and I3 value is coming 1.22 ampere. So after solving the equation, the three current value that is already calculated. So now the current through the 10 ohm, so here current through the 10 ohm, so 10 ohm current, in 10 ohm current, the two current is flowing, one is I1, second is I2. So that is the I1 minus I2, minus 2.35 minus of minus 2.78, so that is plus 2.78, so that is finally coming 0.43 ampere current in 10 ohm. So that is our aim. Question, in the question asks that current through the 10 ohm. So finally we got the current value, that is 0.43 ampere. This is very simple. So next second example is there also, so we'll discuss that problem also. So you see in the second problem, that is a different circuit is here. So in the second problem you can see, so in the second problem you can see there is a different circuit. So here mesh 1, this is mesh 1, this is mesh 2, this is mesh 3. So which mesh is a super mesh, that first we should know. So here mesh 2 and mesh 3, that is a super mesh. Why super mesh? Because a common current source, the common current source value, that is 2 ampere, that is connected between this 2 and 3. So we can say that is a super mesh. So first we will write the equation for the mesh which is not a super mesh. So here mesh 1 is not a super mesh. So for the for this mesh, the equation is, that is 50 minus 10. In so you can see the 10 ohm, in 10 ohm, that is I1 is flowing and I2 is also flowing. I1 I2 direction is opposite, so minus 10 I1 minus I2. Then coming to the 5 ohm, so in 5 ohm, that is I1 is flowing and I3 is also flowing. I1 I3 direction, that is opposite, so minus 5 I1 minus I3 equal to 0, that is equal to 0. Sorry, this should be equal to 0, this should be equal to 0, this is equal to 0. Then after solving the equation, so finally you will get 15 I1 minus 10 I2 minus 5 I3, that is equal to 50 here. So 50, that is taken to that side, so that is 50. So now the first equation that is done. The second equation, so coming to the second equation means the current equation. So current equation for common current source, that is 2 ampere. So here you can see, so let me remove this. Yes, so for common current source, the current source direction is like this, and between I2 and I3, so I2 direction is like this and I3 direction is, that is opposite. So we will write, that is I2 minus I3 equal to 2. I2 minus I3 equal to 2. That is the current equation for that common current source. So that is equation number 2. So first equation done, second equation done, then third equation. So coming to the next slide. So here you can see the third equation. So third equation is the outer path. In the outer path you have to apply KVL. So outer path means, you can see the, again you see the circuit diagram, the outer path. So outer path means the here the this 10 ohm, 2 ohm, then 1 ohm, then 5 ohm, and this branch will not be considered. This branch will not be considered. While applying KVL in the outer path, always remember the common current source branch, that should not be considered. So here after applying KVL in the outer path, the equation that is coming, that is minus 10 I2 minus I1 minus 2 I2, then minus 1 I3 minus 5 I3 minus I1 equal to 0. So after solving, this is coming minus 15 I1, then minus 15 I1 plus 10 I2 plus 6 I3 equal to 0. So after solving the three equation, the three unknown variable, that is I1, I2 and I3, that is coming. So after solving the equation, I1 is coming 20 ampere, I2 is coming 17.6 ampere, I3 is coming 15.33 ampere, and in the question it is asked that current through 5 ohm resistor. So you see current through 5 ohm resistor. So in the previous slide 5 ohm resistor is connected across here. So here 5 ohm resistor is connected. So in 5 ohm resistor current I1 is flowing, current I3 is flowing. So our concern is with the current I1 and I3. So what is the value of I1 and I3? You see, so that is the I1 value, that is 20 ampere, I3 value 15.33 ampere. So here that is 20 minus 15.33, that is coming 4.67 ampere. So this is the final current coming through the 5 ohm resistor. So current through the 5 ohm resistor, that is coming 4.67 ampere. So this is very simple problem. So hope you understand well. Thank you.